Okay, this is a video about how I'm trying to adopt lithium iron phosphate for battery for uninterruptible power supply UPS. So here is the battery. Let me show you. It is in configuration 8S2P, like nominal 24 volts, and here is UPS already with closed box. And here is how the battery is visible if remove this bottom part of case. So let's go to the issue what I had. So the question is how to balance your battery. Use top balancing or bottom balancing. And here is the story. Battery was top balanced and fully charged. And here is beginning how it was started to discharge. Please ignore this gray jumping line because it's first self of battery and iCharger X8 measuring voltage with peaks because of this pulse usage of current from battery. So battery was like in the same level of voltage for each cell, and it was discharging. Okay, let me describe quickly what is the battery. Battery capacity around 30 amp hours. The difference between 200-300 milliamps for cell. Resistance is around 2 milliohms, measured correctly using AC method. So getting back to the discharge curve. This is data collected by iCharger, as I said, in monitoring mode. So we see that the voltage was pretty consistent and the deviation between cells was pretty low, around up to 20 millivolts, which is quite good, I will say. But as close the battery became discharged, the balance started to grow, this balance. Yeah, let's zoom into this part. So we can see it better that voltage between cells became higher and higher, and cell number 2, which is this one, and number 8 became lower than other cells. And while in this case trouble happened with cell number 8, it reached 2.3 volts, which is threshold for BMS to disconnect, but cell number 2 was very close. And later we will be focusing on this cell number 2. This is this color line, see? So what happened? BMS disconnected on 2.3 volts, and in this case UPS next time when AC will be recovered will start in failure mode. So it will not wake up automatically and will not connect AC voltage to the output to power your load. So that's the problem, to avoid BMS disconnection when a battery fully discharged. And you see that when at that point difference between cells became up to 400 millivolts, which is quite high. So the question was what to do, and I have decided to try bottom balancing. And now I'm switching to next window. What I have here, I charged the battery for a few amp hours to discharge it again, and here is the story that we see that actually cell number 2 this time showing like trouble, reaching 2.3 volts to disconnect by BMS, while cell number 8 already was somewhere here. It was not a problem at all. So what I did next, I tried to balance on bottom, and we see that cell number 2 was kind of not the same behavior, like it was not balancing. All other cells from 1, 3, 4, 5, 6, 7, 8 was discharging, and they spent around 300-400 milliamp hours. After that I discharged up to 2.5 volts with balancing as well, and we spent around 40 milliamp hours by reaching 2.5 volts per cell. I gave 4 hours for resting and did this discharge again, like a few times, to be sure that bottom balance is complete. Then what I did charge up to 3.45 millivolts per cell with no balancing. There is this way. And what result we got? Please ignore this red line for current. It was not enough input voltage to keep this current. So let's zoom into this part and I will show something interesting. What is interesting, this time cell number 7, this green one, which I turn off on, reached the target voltage first of all, and current at this point started to drop, not drop, but iCharger started to limit current, of course, to keep this voltage, which is set in the program of charging. And when cell number 2 reached the same level and current continued to drop, then cell number 7 started to drop, which is quite okay. But what is interesting, that cell number 2 showing it was kind of a most weak cell. So it finished, and let me show you what is important here, that the whole battery voltage reached, take a look here on bottom of the screen when I move this pointer, 27.1 volts, while my target and goal to have 27.6 volts, which is 3.45 multiplied by 8 to have a voltage of the battery, to not charge each cell to 3.6 volts and keep it under that at that level. So the bottom balancing showing like some not so good result. What I did next, I tried to charge to 3.6 just in case, and we see the expected picture that cell number 2 reaching 3.6 volts, while other cells were much, let's say, lower, 3.4 and less volts. And even in this case, our battery didn't reach our target of 27.6 volts at the end. This flat line, it was like 27.34. And what happened next, and that's very interesting. Here is, okay, I have disconnected battery from iCharger and connected to the UPS, which is trying to charge battery to 27.6 without balancing leads, of course. And our cell number 2, which is this curve, this is the point. It reached 3.75, let's say, millivolts, which is a limit for BMS to disconnect to avoid overcharging of a cell, and that's the problem. So when we did bottom balancing of battery to not have troubles when discharging, we have a problem when we do charging, even not to 3.6 volts per cell, but lower, still we have a problem. So there is a question what to do. Either way, it's not perfect in my case. So decision probably will be that I have to use top balancing to avoid troubles on top, and for example have possibility to check what is balance at random point of time when I check battery. But I will also have to limit, by the way, did I show this? This is load in watts on AC output, and this is battery voltage when UPS will disconnect it depending on what is load. And here is this value divided by 8 to see what voltage will be on per cell. So this low level, it's not critical, let's say, because it's reaching quickly, but the problem unbalanced. So I will need to adjust voltage on UPS when it must disconnect battery. And I know how to do it, and that's what I will do. But my decision to use top balance at the end for this application. That's it. I hope it was interesting and useful for you.